I think I've said this before, but a picture is worth 1,000 words. These histograms do a mighty fine job of showing the distribution of these quantitative variables. But oftentimes, pictures do not stand alone. They have captions that help describe what you see. With histograms, these captions could be descriptive statistics that tell us the shape, center, and spread of the distribution. Greetings, folks. Welcome. In this video, we're going to cover some statistics used to describe the spread of a distribution. We'll talk about the range, the first and third quartiles, and then the interquartile range. In a different video, we'll talk about the variance and standard deviation. The range is the difference between the maximum and minimum values, so it's the ultimate measure of variable spread. Here's a simple data set with 4 observations where the maximum is 24 and the minimum is 17. This gives us a range of 7. A feature of the range is that it's highly influenced by outliers, that is, observations that fall outside the pattern of most of the data set. If we add a person that is 72 years old to our data set, the range increases from 7 to 55. Because the range is so heavily influenced by outliers, it's not a particularly useful measure of the spread if you have a skewed distribution. Even so, we often report the minimum and maximum values. These are the statistics used to calculate the range when we're describing a variable. The first quartile, which is also known as the 25th percentile, tells us a value for which 25% of the observations have smaller values and 75% of the observations have larger values. You might recall from a different video that the median, which we called the 50th percentile, is the value for which 50% of the observations have smaller values and 50% of the observations have larger values. So we can think of the 25th percentile, or the first quartile, as a value that splits the bottom 50% of the observations in half. A way to visualize the first quartile is to sort the data set in ascending order, that is from smallest to largest, and find the value for which 25% of the observations have smaller values. Here's a variable of a person's age with 5 observations: 17, 21, 22, 24, and 72. So let's first find the 50th percentile, which is 22. Now, if we think of the 25th percentile as splitting the bottom 50% of the observations in half, we want to focus on the values 17, 21, and 22. This is a case if you include the median in the bottom half of the distribution. With these 3 values, which is an odd number, you see that the value 21 splits the bottom half of the distribution. So 21 is the first quartile, or the 25th percentile. Now suppose that we don't want to include the median in the bottom half of the distribution. If we exclude the median, the bottom half of the distribution is 17 and 21, which is an even number. So now we take the average value of these 2 numbers, which gives us 19. So that's 17 plus 21 is 38, divided by 2 is 19. And that's the 25th percentile, or the first quartile. You might be wondering which is the correct approach, and as it turns out, both are acceptable ways of calculating the first quartile. Let's look at the formulas in Excel. Here's a data set that we just looked at, and using the Excel formula equals quartile.inc, then a parenthesis, then you put in the range, so you have 5 observations. Let's say those observations are between B2 and B6. You say B2 colon B6 for the range. Then you put a comma 1, telling Excel it's the first quartile. Then you close a parenthesis. It gives you a first quartile, or a 25th percentile, of 21. To interpret the formula, the part quartile refers to quartile. INC tells Excel to include the median when looking at the bottom half of the distribution. And then, of course, you put in the range of data to tell Excel the cells it should be looking at. And the number 1 means that we want the first quartile. You can use the Excel formula quartile.exe, parenthesis, then the range of data. So this could be between, these 5 observations could be between B2 and B6, comma 1. And of course, you guessed it, the part exe tells Excel to exclude the median when calculating the first quartile. This gives us a 25th percentile, or first quartile, of 19. If you don't want to worry about adding an INC or EXC to the formula, you can just use the formula equals quartile, parenthesis, then the range of data, comma 1. and then close parenthesis. Excel recognizes this formula for the first quartile and actually treats it as the version with the INC add-on. So I guess you could say that if the user does not specify which approach to use, Excel will use the approach of including the median when it's calculating the first quartile. If you're a student taking one of my classes, you should use this approach of including the median in the bottom half of the distribution, which means that you can use the plain old Excel formula equals quartile, and then you put in the range of data, comma 1. Of course, those are in parentheses. If you enjoyed learning about the first quartile, then you're going to love learning about the third quartile. The third quartile, also known as the 75th percentile, tells us a value for which 75% of the observations have smaller values and 25% of the observations have larger values. Let's look again at our data set with 5 observations of people's ages. So you got 17, 21, 22, 24, and 72. With a median of 22, to find the third quartile, you focus on the top half of the distribution. And if you include the median when calculating the third quartile, the values are 22, 24, and 72. This makes 24 the third quartile. Now let's exclude the median from our calculations of the third quartile. Then the two values at the top of the distribution are 24 and 72, which is an even number. And the average of these two observations is 48 years old. The Excel formulas for finding the third quartile, these should be pretty intuitive based on what we learned about the first quartile. It's equals quartile.inc. That's if you want to include the median. And then you give it the range of data. And here you put a comma 3 because it's the third quartile. Or you could use equals quartile.exe. So here you are excluding the median from the calculation. Or you can just use plain old equals quartile and put in the range of data, comma 3. If you're a student taking one of my classes, you should use the basic Excel formula of equals quartile, put in the range of data. So again, if you had 5 observations between cells B2 and B6, you'd put B2 colon B6, comma 3. The first and third quartiles are often used together because the difference between these values tells us the range of the middle 50% of the distribution. That is, the first quartile has 25% of the observations below it, and the third quartile has 25% of the observations above it. So that middle 50% of the distribution is between the first and third quartiles. This range is often referred to as the interquartile range. A nice feature of the first and third quartiles, and therefore also the interquartile range, is that they are not influenced very much by outliers. Since the 25th and 75th percentiles, or the first and third quartiles, are not influenced by outliers, they're commonly used as a group of 5 statistics to describe a distribution with a skewed shape. This group of statistics, called the 5-number summary, includes the minimum, the 25th percentile, or the first quartile, the median, which is the 50th percentile, the 75th percentile, which is the third quartile, and the maximum. With these statistics, you can calculate both the range and the interquartile range of the distribution.